In this lesson, we're going to talk about solving right triangles, which means finding all three angle measures and all three side lengths of a right triangle. So in order to do this, we're going to need our trig ratios that we talked about in our previous lesson. And we're going to use those trig ratios to find missing sides or angles. So if we're missing an angle, we have to use the inverse trig function. So these are inverse operations, just like addition to subtraction, multiplication to division, and squares to square roots. So these are operations that cancel each other out. So instead of having another operation, we just call it the inverse of the trig function. So for example, if I have the tangent of A equals 1, A is the angle measure. So whatever is in that function is the angle measure. So if I want to figure out what the measure of A is, what I would need to use is the inverse function. So since this is starting out with my tangent function, so this is the tangent of A is equal to 1. What I want to do is I want to use the inverse, and I'm going to use that inverse on both sides of this function. So the opposite of the tangent function is the inverse tangent, which looks like this on a calculator. So it's tangent, and it looks like it has a little exponent of -1. So that's the tangent inverse, and if I do it on one side, I have to do it to the other. And so what that does is that the tangent inverse and the tangent cancel out and just leave me with that angle A. So this is going to tell me the measure of angle A. I'm going to use my calculator to find the value of that statement right there. So right now, on my regular Desmos calculator, I just see sine, cosine, and tangent. So if I click on the function button here, switch from main to function, notice that below each of these trig functions is the inverse. So to find this, I'm going to type in the tangent inverse of 1, and that gives me my degree measurement. I do make sure that my calculator is in degree by checking this toggle switch to make sure that it says DEG. So make sure that you're getting those numbers that make sense for degrees. So here, if the tangent of an angle is 1, then the measure of that angle is 45 degrees. So we use that inverse trig function to figure out what the measure of the angle is. So let's look at this next one. All right, so this one originally is using the sine function. So the sine of angle A is equal to 0.35. So the ratio of those two sides that were given would be some ratio that equals 0.35. Now I want to figure out what I need to use to cancel out this sine function. So the opposite of sine is the sine inverse, or the inverse sine. So I'm going to use the sine inverse, and if I do it on one side, I have to do it on both. So to figure out what the angle is going to be, I use the inverse function, which cancels that out, leaves me with only the angle over here, and then I'm going to type this other side in my calculator. So I go to function, inverse sine, and then I type in that ratio, 0.35. So the measure of angle A, and this one isn't a whole number, but notice that my instructions say to the nearest tenth of a degree. So this would be about 20.4. The next number is an 8. So that saying is 5 or more, up the score. So I'm going to round this up to 20.5. So the measure of angle A is about 20.5 degrees. Since I rounded, I'm going to use my approximation sign. All right, so looking at our next one, this one is starting with the cosine of angle A. So the cosine of angle A is equal to 0.64. So to cancel out that cosine, I need to use its inverse. So the cosine inverse will cancel that out, but if I do it to one side, I have to do it to both. So I'm going to use the inverse cosine. Once I do that, it'll leave me with the measure of angle A. So I'm going to go to function, inverse cosine, and then I'll type in the ratio, 0.64. And so this one is about 50.2 and then the next number is a 0, so I'll leave it there, 50.2 degrees. All right, here on our last one, we have that the cosine ratio is negative 0.23. So if we start working with this one, we have the cosine of angle A, and that ratio is equal to negative 0.23. And to solve, I want to cancel out that cosine, so I use the inverse operation, which is the inverse cosine. So that'll cancel it out. And the measure of angle A, and then I'm going to type that one in. So this one is the inverse cosine of negative 0.23. All right, so notice that this one gives me a 100.3 degree angle. So let's ask a question about if this makes sense. So the question is, if I'm working with right triangles, can you have a 103 degree angle in a right triangle? So if you think about this, the total sum of a triangle is 180 degrees. If one of the angles is a 90 degree angle in a right triangle, the other two have to add to get 90. There's no way that you can have a 103 degree angle. So if you are finding the cosine of something that is negative, that is not going to be part of a right triangle. It's going to create too big of an angle to be part of a right triangle. So this is an answer. This is what the calculator gave us, but it's kind of invalid because it doesn't really make sense in terms of right triangles, which we're working with right now. So if you get an answer that's bigger than 100, that's kind of a sign that something's going wrong. All right, so here we have a right triangle, and we are given two side lengths. So we want to solve this right triangle, which means I want to know all three side lengths and all three angles. So if I'm given two side lengths, the first thing I'm going to do is find the third side. So to find the third side with two sides, I'm going to use the Pythagorean theorem to find the third side. So looking at what I have, these are the legs of the right triangle, and I don't know the hypotenuse. So I'm going to find that third side using the Pythagorean theorem. So when I plug these in, let me get rid of my calculator for a second. When I plug these in, that's going to say 8 squared plus 10 squared equals c squared. So if I keep going, 64 plus 100 equals c squared. And so to find the value of c, I need to take the square root. So c, and let's go on and approximate it. If it's 164, I'm going to approximate that by using my calculator. So that's going to be approximately, let's go to 1 decimal place. So that'll be about 12.8. So we have now estimated that this third length is 12.8. So now I have the three side lengths, and I need to find the angle measure. So to find an angle measure, all I know is that I have a right triangle. To find the other angle measures, I'm going to use an inverse trig operation. So I'm going to set up a ratio based on what I have. Since I estimated the hypotenuse, I probably don't want to use it. So let's say that we're going to focus on finding angle D. So if I'm going to focus on finding this angle here, angle D, what I need to do is think about what place these two numbers fall in. So in relation to angle D, the 10 here is opposite, and the 8 is adjacent. This 12.8 that I estimated is the hypotenuse. So if I want to use the exact numbers, the 10 and the 8, I need to use the opposite and the adjacent. So opposite and adjacent are part of the tangent ratio. So just to set up this thing, I'm going to use the tangent of angle D, and I'm going to set that up to the equal to the ratio. So the opposite is 10 and the adjacent is 8. So here's what this equation looks like before I know what the angle measure is. So what I'm trying to do is I'm trying to solve for this angle measure D. So since this is the tangent function, to get the D by itself, I need to use the inverse tangent. So I'm going to use the inverse tangent of both sides. So I've got it here, and over here it's going to cancel it out and leave me with the measure of angle D. On the other side, I also need to do the inverse tangent. So I'm going to do the inverse tangent of 10 over 8. So I'm going to type it in like this. And you might say, but that can be reduced. Let's see if it'll change it if I reduce it. So if I had reduced 10 over 8 to 5 over 4, I would get the same answer. So I can put in the unreduced ratio and get the same answer as if I had already reduced it. So if I want to round this angle measure to the nearest tenth, the measure of angle D is going to be approximately 51.3 degrees. So angle D is about 51.3 degrees. So all I have left is to find angle F, and that will give me all three sides and all three angles. So now that I have two of the angle measures, I have the right angle and I have this 51.3 degree angle, I can find the last angle measure using the triangle sum theorem. So the triangle sum theorem says that all three angles have to add up to 180. So I'm going to say 90 plus 51.3 plus whatever the measure of angle F is going to be equal to 180. So if I solve this, 90 plus 51 will give me 141.3. So what I have so far is the 141.3, and then I'm just going to take that away from 180. So 180 minus 141.3 is 38.7. So the measure of angle F is going to be about 38.7 degrees. So when we're solving a right triangle, that means find all of the measures. And we can do that if we have two side lengths. So looking at the next one, you might want to pause the video and try this one and then see if you got it correct. Looking at this one, so we're starting off the same. We are going to find the first thing we're going to do is find the third side. So since I have two sides, I'm going to use the Pythagorean theorem to find that third side. So I'm going to look at what I have. Since the 7 is across from the right angle, that's the C. So I'm going to use A is 3, and I'm going to figure out what that B measurement is. So when I plug this in, I have 3 squared plus B squared equals 7 squared. So this is 9 plus B squared equals 49. So B squared is going to equal 40. So I need to find the square root of 40 to find that side length. So if I round this to the nearest tenth, that will say that this last side length, which is LM is approximately 6.3 units. So now I can say that this is about 6.3. One way I can check myself is that the hypotenuse should be the longest side of a right triangle, and here it is. All right, so now that I have all three side lengths, the next thing I'm going to do is I'm going to find an angle measure. And to find an angle measure, I have to use that inverse trig. So if I want to find angle L first, and I want to use these two numbers that were given to me. This 3 is opposite of angle L, and this 7 is the hypotenuse. So if I need to use the opposite and the hypotenuse, that is the sine ratio. So, all right, so this is the sine of angle L is going to equal 3 over 7. So to solve that, to find the measure of angle L, I need to use the inverse operation. So the inverse of the sine is the inverse sine. And I do that on both sides. On the left side, it just cancels out so that I'm left with measure of angle L. And then I'm going to use my functions to type that in. So the inverse sine of 3/7 is about 25.4 degrees. So now I know that the measure of angle L is about 25.4 degrees. So the last thing we have to do is find an angle measure. So we're going to find that using the triangle sum theorem, which says that all three angles should add up to 180. So I'll do 25.4 plus 90 plus whatever angle N is going to equal 180. If I add 25 to 90, that is 115.4 plus whatever that missing angle is will equal 180. So the measure of angle N, I'm going to subtract that 115.4. So 180 minus 115.4 gives me 64.6 degrees. So if we have two side lengths, that's what we would use. So now, what if I'm given one angle in one of the sides? So the easiest thing to do if I'm given one of the angles is to find the third angle. So the first thing I'm going to do is find that third angle using the triangle sum. So I'm going to look at the two that I have. I have the 90-degree angle because it's a right triangle, and the 20-degree angle, and I need to figure out what's left to equal 180. So 90 plus 20 is 110. Then I take that away, and I find that the measure of angle S is 70 degrees. So not a special right triangle. In order to find a side measure, I am going to use a trig ratio. And so it doesn't matter which one I want to find. So I'm just going to choose one of these to find. And maybe the first one I want to find is ST. So it also doesn't really matter which angle I use. So maybe I want to use this 70-degree angle that I just found. So if I look at this 70-degree angle, the one that I'm trying to find is adjacent to that 70-degree angle. And then the 15 is the hypotenuse. So the trig ratio that I'm going to use is adjacent over hypotenuse, and that is the cosine ratio. So I have my angle measure this time. So this is going to be the cosine of 70 degrees. So if I have the angle measure, I put it into that function. Now I'm going to throw a variable in here. Let's call this one x. So the adjacent here is x, and the hypotenuse is 15. So I want to solve this, and to solve this, I just need to multiply by 15 this time. That's the inverse operation of division. So that'll cancel out, and I'll get that x is approximately 15 times the cosine of 70. So that's going to be about 5.1 units. So now that I have this, I can find the last side measure with another trig ratio, or I can use the Pythagorean theorem. So let's just go about this with another trig ratio. So if I use this 70-degree angle again, let me throw a y down here for my next side length. I just found that the adjacent side is 5.1, and I want to find the other side now. So if I'm looking for y this time, and I want to use that 70-degree angle again, this time I'm going to have to use the adjacent in the hypotenuse. So adjacent, or sorry, it's not adjacent, this is opposite. So it's opposite of that angle. So I'm using the opposite in the hypotenuse, which is the sine ratio. So for this one, I'm going to take the sine of that 70-degree angle, and this will equal the opposite, y, over the hypotenuse, 15. All right, so to solve this, again, the variable's being divided, so the opposite is multiplying. I'm going to multiply by 15. So 15 times the sine of 70 is going to be about 14.1. So let's check this and see. Now that I have this third side, I said we could also have used the Pythagorean theorem. It might not be exactly with rounding, but it should be close. Let's try it. 5.1 squared plus 14.1 squared is 224.82. And then if I do 15 squared, that's 225. Those are pretty close. The reason why they are not exactly the same is because we had rounded. So there will be a little bit of variation because of the rounding. All right, so here's another one that's given an angle and a side length. So the first thing we're going to do is find the third angle using the triangle sum. So I have the 90-degree angle, I have a 48-degree angle. I need to figure out what's missing to make 180. So this is 138 all together. And then I'm going to find what's missing by subtracting. 180 minus 138 is 42. So the measure of angle B is going to be 42 degrees. Now I can use either angle to find a side measure using a trig ratio. So I know I need to use this 9. Maybe I want to say that I'm going to use this 48-degree angle this time. So if I'm using the 48-degree angle, that 9 is opposite. And then I have to choose one of the sides to find. It doesn't really matter which one I'd use. So let's say that I want to find side AC. So in relation to that 48-degree angle, this one is adjacent. And the one across from the right angle is the hypotenuse. So let's find the adjacent side first. So if I need the adjacent side and I have the opposite side, opposite and adjacent are part of the tangent ratio. So I'm going to say that the tangent of 48 equals 9 over x. And what we talked about previously is that in our ratios we can switch the places of the cross products and they'll stay the same. So I can rewrite this ratio. If I switch those two things, I'm going to switch it so that it says x over 1 equals 9 over tangent of 48. Those are equivalent because of the cross products being the same. So now, x over 1 is the same thing as x, so I'll have the value of x if I just divide. So I'm going to do 9 divided by the tangent of 48. And so x is approximately 8.1. All right, so now I know that the adjacent side here is about 8.1. Next, I need to find the last side measure using, I can use a trig ratio like we did in the last one, or I could even use the Pythagorean theorem. So let's try this one with the Pythagorean theorem. What I'm trying to find is the hypotenuse. So that would be c, the c value in a squared plus b squared equals c squared. So here's what it looks like whenever we set it up. I'm going to use y for that side measure. So 8.1 squared plus 9 squared equals y squared. So let's go in and do the 8.1 squared plus the 9 squared. Right, and so that gives me 146.61, which is y squared. So to get the y by itself, I'm going to take the square root. All right, and so y is approximately 12.1. Just want to double check and make sure that my hypotenuse is the longest side, and it is. So now I have all three side lengths and all three angle measures. All right, for this last one, let's look at this word problem and draw a diagram to help us set it up. All right, so this one says an antenna is 34 feet tall. So I'm going to draw an antenna. Here's an antenna, and it is 34 feet tall. The wire that supports it is in the ground 36 feet away from the base of the pole. So 36 feet away from the base of a pole is where the wire goes into the ground. So here we have a wire that connects the top of the antenna to the ground. What we are solving for is the angle of elevation. Angle of elevation means from the bottom of the wire. So we want to figure out what this angle measure would be. All right, so I need to look at the angle that I'm working with. Let's give it a name. Let's call it E for elevation. And we're going to assume that that pole is perpendicular to the ground. So if that's true, based on this, here's where the hypotenuse would be. We don't have that. But across from that angle is the opposite side. And then 36 would be the adjacent. So looking at what we have here, we have the opposite and the adjacent. Opposite and adjacent are part of the tangent ratio. So the tangent ratio is of an angle, and I don't know the angle measure yet. So the tangent of angle E is going to be equal to the ratio of 34 over 36. So I need to look at what I would do to solve this. So I need to get that E by itself, and right now it is in the tangent function. So I need to cancel out that tangent function with its inverse. So the tangent inverse will cancel it out, but anytime I do something to one side, I have to do it to both. So I need to find the tangent inverse of 34 over 36. So once I do that, that'll give me the measure of angle E, which is my angle of elevation. So I'm going to use the inverse tangent function, not that one, the one with the -1, the inverse tangent function of 34 over 36. And so the measure of angle E will be about 43.4 degrees. So that's our angle of elevation here. That's the angle that it would have to be from the ground to the top of that antenna in